Okay, so this video is going to be one in which we establish an identity. So we're going to show that cotangent of x plus tangent of x is equal to, for any x, all values, secant x times cosecant x. And there's two basic approaches to establish an identity or prove an identity. Two basic ways, especially for trig equations, trig identities. One is to take the whole equation and rearrange it, multiply on both sides, add on both sides, whatever you need, until you get like sine equals sine, sine x equals sine x. Oh, well, that's clearly true. That's a thing we already know. Or if you get something like um, sine x over cosine x equals tangent x. Well, yeah, that's an identity we already have. So as long as we do valid algebra from one step to the next, and we get something that's definitely true, that means the original was true. So that's one way. But you have to be careful with manipulation that you do every algebra step is reversible. Um, and if there are any questions on what that means, I could make another video clarifying what a reversible algebraic step means, because that's something that's from a previous course, and maybe we need a refresher on that, perhaps. Anyway, onto this example. So the alternative to that is to pick one side or the other and pick, say, the left hand side. I might start with cotangent x plus tangent x. I might start with that and manipulate that using algebra and identities until I get the right hand side. Right? Through some algebra manipulations, I get secant x times cosecant x. That will mean, oh, well, this is it. I've found the thing I wanted. So for this one, I'm going to start with the left-hand side. I think that will be easier because I have a suspicion of how this is going to go. Again, I've never done this one before. As I mentioned in the overview video, I have never done this one. I don't know how it's going to work out. But I suspect I can start with cotangent, oh, that's an eraser, cotangent of x plus tangent of x. Okay, and I'm going to ignore this temporarily. I'm not going to write it, but that's my goal. I want to arrive at that as a result. So I'm first going to rewrite these with sines and cosines. I think that will help. So this is cosine x over sine x plus sine x over cosine x, which doesn't look better, but now I could rearrange this. I could combine into one fraction. I think that's going to work. So this first guy, I need a common denominator. So I need sine x times cosine x in both. So this fraction, I'm going to multiply top and bottom by sine x. And I don't want to like write it in sideways and kind of cram it in there. I'm just going to say I'm doing it, and then I'll just write the result in the next step. So if I multiply top and bottom by sine x, rather cosine x, or cosine x, I'm going to have cosine squared x over sine x times cosine x. And again, I got that by multiplying that fraction on top and bottom by cosine of x rather. You can probably guess what I'm going to do with this next one. And if you might want to pause the video, think about it for a second. So with this fraction, I need a matching denominator. So I'm going to multiply top and bottom by sine x. And I do have room to write it here, but I'll just not write it. I'll just say what I'm doing. So I'll multiply sine x on top and bottom. So sine squared x over cosine x times sine x. Now these two denominators are the same. The order doesn't matter when you're multiplying, right? 2 times 3 is the same as 3 times 2. So those are the same. So now I can combine these two numerators into one fraction. So this is cosine squared x plus sine squared x all over sine x times cosine x. Yeah, this one's working out to not be too bad because we're almost done, at least halfway. Looking at the numerator, you might see right away what to do. This is one of the Pythagorean identities. Cosine squared of x plus sine squared of x. This equals 1. That numerator is 1. So I can do this. This is equal to 1 over sine x times cosine x. Okay. Well, remember, don't forget our goal. I want to have secant times cosecant. That is the goal. So here, well, I can separate this into two fractions. If you have 1/4 times 1/5, That's 1 over 4 times 5. That's the same thing, yes? But you can reverse it as well. You can separate the fractions. So I'm going to do that, and I'm going to have 1 over sine of x times 1 over cosine of x. With this, we're just about done. 1 over sine x, the reciprocal of sine of x, that's cosecant. And the reciprocal of cosine of x, that's secant of x. But that's what we wanted. Now the order is different, secant x times cosine x versus cosine x times secant x, but when you're multiplying, the order doesn't matter. So these are the same thing. So let me erase this, and I can say that that is completed. I'm going to zoom out and try to get the whole thing visible. So there was what? 1, 2, 3, 4, 5, 6 steps. Not too terrible, but we got the goal. So that's that.